Welcome back to our deep dive series, Into the OEIS,
Ah, yes.
the online encyclopedia of integer sequences.
One of my favorite places to spend a Friday night.
If you're joining us for the first time,
Oh, that's great.
the OEIS is a vast online database of
You guessed it.
integer sequences.
Integers all the way down.
And it's truly a gold mine for anyone who studies number theory.
That's us.
And that's why we're dedicating this entire series to it.
To really pull out some of the gems.
The coolest entries in the OEIS.
Absolutely.
And today we're going to dive into a sequence that seems,
Unassuming. First.
deceptively simple.
Yes.
000122. You might also know it as the expansion of the Jacobi Theta function.
Theta 3 of x. But don't worry.
Don't let the fancy name scare you.
We're going to break it all down.
Nice and easy.
Even if you've never seen a theta function before.
That's right.
So let's just start with the basics.
Okay.
What does A000122 actually look like?
Where are we at?
Let's look at the first few terms.
Okay.
1,
Okay.
2,
2, 0,
0,
0,
2,
0,
yeah.
0.
Okay.
Okay, so I'm seeing...
Now, what's the pattern?
Okay, it looks like it's just zeros and twos. But there's something about the placement of those twos.
Yeah. Where are they?
That's what I'm trying to figure out.
Okay, you got it.
I don't
They
have-
show up in the square positions.
Oh,
1, 4, 9, 16,
okay.
and so on.
Gotcha.
And that visual pattern,
Okay.
that's directly related to the mathematical definition of this sequence.
Oh, really?
Yeah.
Okay, so what's the connection?
A000122 represents the number of ways you can express an integer
Okay.
as the sum of two squares. So, for
I
example,
know.
the first term is 1,
Right.
because there's only one way to write 1 as the sum of two squares.
Right. 1 squared plus 0 squared.
Exactly.
Yeah.
The second term is 2, because there are two ways to write 4 as the sum of two squares.
Okay, so 2 squared plus 0 squared and 0 squared plus 2 squared.
You got it.
Okay. So every time we hit a perfect square in the sequence,
Okay.
we get a 2
Yeah.
because we have those two symmetrical representations.
Ah, I see.
Yeah.
That makes a lot of sense.
Okay, good.
Okay, so this is where the
big scary
Jacobi Theta function
zeta 3 of x.
comes in.
Yeah.
Yes. Okay, theta functions.
I
I have to admit, I kind
a
of
little mysterious.
a little mysterious.
Yeah.
For those of us
For those of us who haven't really
who haven't worked with them.
worked with them much,
Yeah.
they can seem a little intimidating at first,
Yeah.
but honestly, at their heart,
Okay.
they're just infinite sums
Okay.
with a specific structure.
Okay.
In this case, the formula for theta 3 of x
Okay.
is a sum of terms
Right.
that look like x to the m squared,
Okay.
where m runs through all the integers.
Okay, so each term represents a possible square.
Okay.
And when you expand that infinite sum,
Okay.
you get a power series
Right?
where the coefficients of each x to the n term tells you how many ways
Yes.
you can express n as the sum of two squares.
Ah, okay.
Okay.
So the coefficients in the expansion of theta 3 of x
Yes.
are literally
Absolutely.
the terms of our...
A is 000122 sequence.
That's right.
Beautiful connection.
That is really cool.
It is.
So we have this seemingly simple sequence
Yeah.
and this really powerful mathematical function.
And they're tied together in
Yeah.
this really elegant way.
That's amazing.
I know, it's pretty cool.
Okay, so we've established this connection
Yeah.
between the sequence and the theta function.
Yep.
So where do we go from here?
Well, let's explore some of the implications of this connection.
Okay, I'm ready.
Okay, good.
So we've got this like really cool connection
Mm.
between this sequence
Yep.
and the theta function.
Mm-hmm.
Where can we go with this?
Well, remember how we were saying like A000122?
Yes.
It tells us like how many ways we can represent an integer,
As the sum of two squares.
right?
That was like the core definition.
Exactly.
Yeah.
Well, there's actually a formula
Oh,
that relates the 3 of x
okay.
directly to R2 of n.
R2 of n.
Yeah, you know, the math notation
What?
for the number of ways to represent n as the sum of two squares.
Okay, so by understanding this sequence
Yeah.
and its connection to the theta function,
Uh-huh.
we're basically like unlocking
You got it.
this classic problem in number theory
It's a classic problem.
of representing integers as sums of squares.
Exactly. And
Right.
that's just the beginning.
Oh, there's more.
There's always more.
Okay, hit me.
Well, A000122 is also linked to things like Ramanujan's theta functions.
Oh, Ramanujan.
Yeah.
Okay, His work is always so fascinating.
It is, right?
What's the connection there?
Well, Ramanujan developed his own set of theta functions.
Okay.
And they have like wide-ranging applications in number theory.
Okay.
And guess what?
Yeah.
A000122
Yeah.
is related to one of them.
No way.
That's wild.
I know.
Okay.
It's really cool.
So this one sequence is like
yeah.
a bridge connecting all
these different areas.
Different parts of number theory.
It really is.
It's amazing.
Yeah, and it goes even beyond number theory.
What?
Yeah.
Holy.
For instance, a 000122 has a connection to the Liouville function.
The Liouville function.
Yeah.
I'm not familiar with that one.
So the Liouville function,
okay,
it basically assigns a value of 1 or -1 to each positive integer based on the number of crime factors it has.
Okay.
So it might seem kind of unrelated
a little bit,
to what we've been talking about, but there's a link.
Wow.
I know it's pretty surprising.
Yeah.
You wouldn't expect that. So we've got the theta functions, we've got Ramanujan, we've got the Liouville function.
Yeah.
It feels like the deeper we dig into A000122, the more connections we find.
That's the beauty of math.
It's true.
Right.
It's all connected.
Yeah, and there are even more connections we could talk about.
Oh, really?
Yeah, like A000122.
Yeah.
It's related to things like lattices.
Oh, okay.
And modular forms.
Okay, those I'm a little more familiar with.
Yeah, from your studies.
Number theory studies.
Yeah.
But it's just crazy that
I know, it's amazing.
they all tie back to this one sequence.
And it's one simple sequence. It's really cool.
So it's like this one little like key unlocks all these.
It unlocks all these doors to all these different concepts.
That's incredible.
It is.
This is making me want to go back and revisit all my...
Revisit your notes.
Yeah.
Oh, I love that.
Yeah. My number theory notes.
Yeah, you should.
So all these concepts that I learned, like in isolation.
Yeah.
It's so cool to see how they're all
connected. And, you know, if you're looking for like more to explore, the OEIS entry for A000122.
Yes.
It's a treasure trove
it really is.
of information.
Okay.
It's got tons of formulas and references and links to other sequences.
That's a great reminder.
Yeah, you should check it out.
I'm going to have to spend some time there.
Yeah, it's a great resource.
But let's shift gears a little bit.
Okay.
And talk about some of the properties of A000122.
Okay.
Like the sequence itself. What are some of the things that stand out?
Well, there are a few interesting quirks.
Oh, really?
One is the asymptotic mean.
Asymptotic mean. Yeah. Okay, remind me what that means.
So basically, it describes the average behavior of a sequence as you look at more and more terms. So, like, if you took the average of the first 100 terms, you'd get a certain value.
Okay.
And then if you took the average of the first 1,000 terms, you'd get another value.
Gotcha.
The asymptotic mean is the value that those averages approach as you take larger and larger sets of terms.
Okay, so it's like what the average is approaching.
Exactly. As you go to infinity.
I remember that now.
Okay, good.
Okay, so what's interesting about the asymptotic mean?
Okay, so for A000122, the asymptotic mean is 2 pi over 5.
Wait, hold on.
It's pretty wild.
This sequence is just zeros and twos.
I know.
How does pi get involved?
It's pretty surprising.
Yeah.
But that's what makes it so interesting.
Yeah.
Just shows you like the unexpected connections that can pop up.
So these simple terms lead to this behavior that involves pi.
Exactly.
Wow. I'm going to have to think about that for a minute.
Yeah, it's pretty mind-blowing.
Okay, so are there any other, like, surprising properties?
There's one more I want to mention.
Okay.
It involves something called Dirichlet convolution.
Dirichlet convolution.
Yeah.
Okay, for those of us who aren't familiar.
So Dirichlet convolution is basically a way of combining two arithmetic functions.
Okay.
So imagine you have two functions.
Okay.
Let's call them f of n and g of n, defined on positive integers.
Okay.
The Dirichlet convolution of those two functions creates a new function.
Okay.
Let's call it h of n.
Okay.
And the value of h of n is found by taking a sum over all the divisors of n.
Gotcha.
So for each divisor d, you multiply f of d with g of n over d. And add up all those products. That gives you the value of h of n.
Okay, so you're like taking And you're breaking it down.
Breaking it down.
Into its divisors.
Exactly.
And using those.
To combine the values of f and g.
Okay, cool.
Yeah. It's a really important operation in number theory.
Okay.
And there's this conjecture by Werner Schulte.
Werner Schulte.
Yeah.
Okay.
That proposes a specific relationship involving Dirichlet convolution of two functions related to A000122.
Okay.
It's a little technical.
Okay.
Let's go into detail here.
Yeah.
But it's a fascinating area if you're interested in exploring the sequence further.
Cool.
Yeah.
This has been
quite a journey.
It really has.
Yeah.
Like we started with this simple sequence of zeros and twos.
Yeah.
And we ended up talking about
all sorts of things.
Theta functions. Ramanujan's work.
Liouville function.
Lattices, modular forms.
Dirichlet convolution.
Dirichlet convolution conjectures.
It's amazing.
It really is.
How much is packed into this? One little sequence.
So it's like this one sequence. Is this like a microcosm?
Yeah, it's like a
little keyhole.
Into number theory.
The whole world of number theory.
It's amazing.
Yeah, it's really cool.
What do you think are like the big takeaways?
Well, I think the biggest thing is that you should never underestimate a simple mathematical idea.
Right. Like it can lead to...
Yeah, who knows where it could lead?
Oh, yeah.
You start digging, and you never know what you might find.
Yeah, and I think also this is a great illustration of the power.
The power of the OEIS.
Of the OEIS.
So this is just one example.
One tiny example.
Of this
vast universe.
Universe of sequences.
Of integer sequences.
It's amazing.
It's incredible.
So for anyone studying number theory, I think A000122. It's a really valuable
example
of how like a specific problem can connect to these broader ideas, these big concepts.
And I hope everyone listening is inspired to go and like explore the OEIS.
Dig deeper. Find your own favorite sequences.
Maybe even submit your own sequence.
Yeah, it'd be awesome.
Yeah.
Yeah.
Well, thank you for joining us.
Yeah, thanks for having me.
On this deep dive.
It's been a pleasure.
Into A000122.
Absolutely.
We hope you learned something.
And we hope you're inspired.
And had some fun along the way.
To keep exploring.
Yeah. So until next time.
Keep on counting.
Keep on counting.